All right, we're live. Hi, welcome everyone. This is the V Brown Bag. Today is, what is today? Wednesday, August 21st, 2024. I am Damien. I am going to be one of the only hosts this evening. We've got Chris out doing work stuff out of the country. Shala's doing work stuff in the country. So it's just going to be me and our illustrious guest this evening, Reuven. A little bit about the show before we get going. Join the community. We're at V Brownbag on Twitter. You can catch us on YouTube, LinkedIn, Twitch, Threads. If you're one of the three people on Threads, you see all the folks here and all of our Twitter handles. So feel free to reach out and say hello. You can join in the conversation through whatever platform that you're viewing it on right now. And so I am going to go ahead and turn it over to Reuven. Reuven, why don't you go ahead and introduce yourself and tell us a little bit about what you do and what you'd like to talk about tonight.
Sure thing. So, hey, Damien. Hello out there, everyone watching. Oh, am I not on?
Yeah, you are.
Oh, I am.
I meant to. Sorry, I'm new to
That is
this. Oh, I'm messing it all up. You know.
that is
Well,
totally
there
fine.
we go. There's Reuven.
Hey, folks.
We did it.
How many technology people does it take to use a mass technology? So I'm Reuven, and I am a full-time Python trainer. Basically, I go to companies around the world and help their people either learn Python or to improve their skills. I also have courses online, video courses, email courses, newsletters, and I just spend all my time trying to help people either learn Python or improve it. Do a lot with pandas, also do some Git because that's part of that. And one of the things that I see people struggling with when they're working with Python, even if they've been using it for a little while, is something that seems very straightforward and elementary, or it should be, which is sorting. And it's very easy to sort things if they're simple. And when things get more complicated, all of a sudden, a lot of sort of more complicated Python functionality comes to the forefront. So we are going to be talking today about what I call how to sort anything. And I think you'll see that, again, for simple things, it's very simple. But for complex things, it's not as hard as you would think. And hopefully this will pique your interest in doing more Python things. And if people have questions, I'm super, super happy to answer those as well.
All right, I'm going to try to do this. There we
Oh.
go. I figured it out. So, tell us where folks can reach you at, Reuven, if they have any questions.
So they can reach me via email at reuven@lerner.co.il. And my online courses and also information about my corporate training is at learnerpython.com. You can actually email me also at reuven@learnerpython.com, but I'm stubborn and I've been using this domain for a very long time. So there you go. But I'm always happy to hear from people. And I'm on Twitter and Threads and LinkedIn. And I'm super happy always to hear from people around the world with questions, suggestions, thoughts. And of course, if you want to take my courses, I'm especially happy to hear from you. But I hear from many people who aren't necessarily paying customers. And just like I feel very fortunate to have the sort of job that I do, sort of helping people improve their careers.
That's excellent. Did you want to get started on your presentation or chat a little bit first?
I'm happy to get started, and we can chat afterwards.
All right. Well, let's get going. Feel free to take it away.
Fantastic. So as I said, we're going to talk about how to sort anything here today. This is a slide with some of the information about me. As I said, I'm at learnerpython.com. My biggest newsletter is called Better Developers. If you go to betterdevelopersweekly.com, new articles about Python every Monday. And my latest newsletter is something called Bamboo Weekly, where it's puzzles using pandas that comes out every Wednesday, where I take a topic from current events from the news and a real world data set and analyze it. Or actually, I ask you to analyze it. And then the next day on Thursday, I publish my solutions. So let's start with sorting. Sorting is important. And why is it important? Like, why would we ever want to sort our data? I know it sounds kind of trivial, but there are actually many, many, many reasons. We might want to just do it for aesthetic reasons to display our data nicely. We might want to make our messy data less messy. We might want to find the largest or smallest value in a collection. If you want to do that, you got to sort. We might want to, if we're talking about like database records from a company, see which products sold best or sold worst. Maybe you're looking through proposals and you want to know which is going to cost you the most or cost you the least. Maybe you're low on gas or low on a charge for your car if you've got an electric car, and you want to find the closest station where you can charge up or gas up your car. Maybe you're running a company like doing movie streaming and you want to find a film that's most similar, or help your customers find a film that's most similar to the one they're watching now, find similar products like on Amazon. Lots and lots and lots of reasons and ways that you would want to sort. And so Python actually makes sorting very, very easy. If you have a list, and we love lists, and let's say we have a list of integers, you could use the sort method. So I can say my list equals 10, 5, minus 3, 7, minus 2, 4. Great. And then I print it out before. And here, by the way, I'm just using the new-ish functionality in what are known as f-strings. F-strings allow you to put a variable value inside of a string interpolation. If you put an equal sign after it, then it prints the variable name or the expression name equals and then its value. So we will find out, it'll say my list equals and the value. And so if we run this, we see that before, not surprisingly, my list is 10, 5, minus 3, 7, minus 2, 4, what we had before, what we defined. But afterwards, it's sorted from lowest to highest, from minus 3 to 10. Fantastic, right? And this is what many people learn about when they want to sort in Python, and they use it. And there's some problems with it. So first of all, list.sort, it's a list method, so it only works on lists. It sorts from smallest to largest by default. Okay, that's not necessarily a bad thing. But here's the most important thing. It changes the list object itself, meaning that if I run list.sort on a list, then here we go. Let's say I have my list, and then I define another variable, also my list, that also refers to that same list. So now we have two variables referring to the same list. And so now when I print my list, when I print also my list, before we sort, it looks like this, and after we sort, it looks like that. In other words, these two variables are referring to the same list. Calling my list.sort modified the list. And so both variables will now reflect that sort. So that is surprising to many people and a little weird. Moreover, if you try to assign, like if you say, my list equals my list.sort, and I see people do this all the time. Well, my list.sort actually returns none. It's a convention in Python that if a method modifies an object, a mutable object has to be, then it returns none because it modified the object. Why return anything? So many people are surprised that my list here will indeed become none and they lose their data. Or it's like a fantastic way to make sure your backups are running, right? So a better way to sort your things than list.sort is actually the sorted function. And it's a built-in function, so it's not a method that runs just on lists. It works with all iterables. Anything at all that you can iterate over, it can work with. It always returns a list, though, sorted from lowest to highest, and it doesn't modify the source data at all. You could argue that it's like a functional version, functional program. And so it requires slightly different uses, but it's more general purpose, and so I'd say it's to be preferred. So how do I use it? Well, here's my list again, and I run sorted on my list, and it's going to return a list so I can print that. And so afterwards, my list is exactly what it was before. My list has not been changed. And that gives us a lot of opportunities then. We can sort things even if they cannot be changed, even if they're immutable. We can sort things even if we're worried that someone else will be affected by this. We're only affecting ourselves. So wait a second. It's very nice that it's being sorted, but how is it being sorted? And so what sort algorithm are we using? And so it was invented by someone named Tim Peters. And so it's known as TimSort. I kid you not. And TimSort is actually used in a whole bunch of different programming languages, although it originated in Python. And it makes some assumptions about the data that turn out to be accurate for the real world. First of all, it assumes that there are natural runs. It assumes that within our data, there'll be subsets that are already sorted, because that's the way data kind of works in real life. And so given some runs, TimSort then merges them. And if there are no runs like that, then it uses insertion sort one by one by one to put each one of the elements into its place. And so it's kind of a mix of two classic sort algorithms, merge sort and insertion sort. So it's going to do insert, insert, insert into a little run. And when that is all sorted, it merges it with another run. And slowly but surely, it builds up all these runs. And if your data is already partially sorted, this actually can save a lot of time. Well,
I have a
okay.
quick question.
Please, excellent.
Yeah. So you said not just lists, right? So any sort of an iterable, but does the data itself matter? Like, is it only
Yes.
integers? Can it be
No. We're going to
floats
talk
as
about
well?
that. So certainly integers and floats, but
Yeah.
it also will let you sort strings and lists and tuples. And as we'll see in a bit, you can apply your own functions to do more complex objects too.
Awesome. Okay. Well, I won't steal your thunder then.
No, it's fine. It's fine. People love spoilers. So indeed, let's see what TimSort is doing sort of under the hood a bit. And what it does is it compares two items at a time. It's constantly doing these pairwise comparisons. And so it's going to say, okay, I have these two items, A and B. We have to know, is A less than B? Is A greater than B? Or is A equal to B? And so when it's merging or it's inserting, TimSort needs to be able to make this comparison. So if we have a sequence of numbers, then we can just use less than, greater than, and equal. And like that works with numbers. It works with integers. It works with floats. Works fantastically. And we saw that it does. What if we want to sort some strings? So here I'm going to create a list. So I say this is a bunch of words, dot split, that returns a list of words. I say print sorted of words. And sure enough, we get them sorted in alphabetical order. And it might seem almost magical that Python is able to do this, but it actually does this in a very easy, straightforward way. Basically, a one-character string can be compared with less than. And so it's based on the Unicode code point for that one character string. Python does not really have a character type. It just has strings, but a one-character string is easy to think of as a character. So, in fact, I just said a one-character string, right? So it looks at the two of them and it compares them. So what if we want to compare multi-character strings? We compare the characters at index 0, so meaning at the first element. So is word 1 0 less than word 2 0? Then word 1 comes first. But if word 1 0 is greater than word 2 0, then word 2 comes first. Oh, there is a third option, right? What if they're the same? Then we check with index 1, and then we check with index 2, and then we check with index 3 until they are either not the same, and we know which word wins the tie, or one of them is shorter, and then it wins. And so this is just how we look up words in a dictionary, right? The older members of the audience might remember these things called books, right? And they might remember these things called dictionaries, and we go and look things up in them. All right, it's like ancient history now, I know. But like that's the way that Python is also making the comparison letter by letter. And by the way, if they're equal, then it just returns word 1. Like, who cares?
So will this go all the way? So like if a word,
yes.
If there was two identical words and one of them ended in S, it would still put the S second?
Yes, exactly
Okay.
right.
Cool.
So, right, this is exactly how we do it with dictionaries. But here's not Python dictionaries, like human dictionaries. But here's the thing. It works this way on all Python sequences. So if I have a list of strings, I have a list of lists, I have a list of tuples, that's okay, right? Because so it goes in a string one element at a time. It goes in a list one element at a time. It goes in a tuple one element at a time. Because lists and tuples implement less than in the same way. So you can say, is this list less than that other list? Is this tuple less than this other tuple? Because what are we doing? We're checking one element at a time inside the list, inside the tuple, until we have a tiebreaker. So let's see an example of this. So if I have list 1 is 10, 20, 30, and list 2 is 10, 20, 15, so is list 1 less than list 2? Is list 1 greater than list 2? Well, it's not less than, and it is greater than. Why? Because the tiebreaker in index 2, where we see that list 1 has 30 as opposed to 15. What if I have different types? So what if my list is 20, B, A, 10, and 30, and now I can sort. So we've seen that we can sort a list because it contains integers or strings, right? Those are fine. But what if we mix it up a little bit? And the answer is that Python gets very angry. And Python's like, what do you want from me? Right? Like less than, how am I supposed to compare with less than an integer and a string? That doesn't even make sense. And by the way, I'll say that in Python 2, we're nowadays in Python 3, but in Python 2, the previous version, it would allow you to do this, and integers were always less than strings, which was just like how the language was defined. but this was not at all obvious to newcomers to the language who would get an answer. And so it's better to get, Python has this principle or a number of principles. One of them is that if something is ambiguous, don't guess. Better to be explicit about it. And that's what's happening here. So the assumption was better to give people an error if they're trying to sort a mixed list than to actually try to do something smart. Well, what if I don't want to sort from smallest to greatest? What if I want to sort in the reverse direction? That's okay. I just say sort of my list, and then I pass a keyword argument, reverse equals true. And then what do you know? We get it in reverse order, 30, 20, 10. So all it does then is reverses the comparison. So it says, oh, is A less than B? Well, if so, then we actually want B instead of A. And it just does that through the whole thing. What if I want to sort a list of words, but I don't want to sort the words alphabetically? What if I want to sort them by their lengths? So I no longer want TimSort to say, is word 1 less than word 2? Rather, I want to check if the len of word 1 is less than the len of word 2, right? So now here's the thing. I could create two lists that are the lengths of the words, right? A length of integers, the length of integers, but I don't want that. I don't want to have my result be the lengths of the list of lengths. I want to still have a list of words. I just want to sort by the length. And so how am I going to do that? And it turns out that sorted has an additional parameter called key. And so if we have a function f, we can compare a and b, so f of a and f of b. So in order to do that, we can call sorted with key equals f. In other words, and I'm not talking about music here, right? But I say key equals f, and then that function is then going to be applied to each element, and the result of that function is going to be used in the sorting. So here, for example, I want to sort the words by length. So I call sorted with key equals len, and this is what it looks like. Notice, by the way, I am not invoking the function. I'm not saying len parentheses, because I am asking sorted to call the function on my behalf. And if you've never seen functions passed as arguments before, functions in Python are not just verbs, they're also nouns. They're also objects that we can pass around. We can assign them to other variables, and we can pass them, as you see here, to functions. So sorted is going to invoke len on our behalf once for each element, and then it's going to use that to sort the words. And sure enough, now we get them not in alphabetical order, but rather we get them in size order from smallest to largest. So, and this key function, this is the power of the sorted function, because we can pass in lots of different things. So any function, in fact, that takes a single argument and that returns a value that can be compared with less than, and that's known as a comparable value. Most basic values in Python are comparable. We've said already, integers, floats, lists, strings, tuples, all those could be compared with less than. And so we can pass a function that returns any of those and we'll be fine. So for example, if I say sort of words key equals len, sort the words by length. I say sorted numbers key equals abs. We use the absolute value function and we will get the numbers back by that. So words key equals stir.lower. So now what's going to happen, we are going to apply that method stir.lower to each of the strings, and then we will sort them case insensitively, right? And so we can pass a method, because normally I would say like word.lower or something. I would invoke it on the actual string, but every method in Python can be invoked instead of that way by saying the class name dot the method name, and that's your function that you're going to pass, and that works just great. And really, like, I see people do this all the time. Don't pass the key function with parentheses. First of all, it's just not going to work because the function needs to have an argument in it. But second of all, you don't want to be executing it. You're sort of outsourcing the invocation of that function to sort it. So I don't say key equals abs with parentheses, rather I say key equals abs, and then we have good abs. Okay. And that's because, right, as I said, we have to pass a callable to key. And any callable can be passed. Well, what if I have a list of lists and I want to sort them by the length? Then I just say key equals len, just like with strings. What if I want to sort them by the sum of the numbers they contain, right? So I've got a list of lists, and each inner list contains integers, and I want to sort them from lowest to highest by their integer contents, by the sum of their integers. I just say key equals sum. And then it's going to call some on the first list, some on the second list, some on the third list, and so forth. And then it will sort them by those sums, right? And so we can also write our own key functions, or better yet, we can pass our own functions, anything we've defined, as long as our function takes one argument, and as long as it takes an element of what we're sorting, and whatever it returns will determine the sort order. Again, the value must be sortable, must be comparable, and the value that we return doesn't need to be the same type as the input. Remember, len took strings and lists, but it returned integers. So for example, let's say here I want to sort integers by the number of digits. Okay, so I'm going to define a function by digit count, and I'm going to first turn my number into a string, and then I'm going to return the length of that string. So now I'm going to say print sort of numbers key equals by digit count. By the way, the whole thing of like by something, that's like a convention that I use for myself. You are welcome to steal and use it. I just find that it makes my code a little more readable and obvious. So what's going to happen when I do this? Well, indeed, I get back 1, 30, 40, 500, 100, 200, 2000, 1000. Why? Because it's sorting from the smallest, the shortest, to the longest number, not the greatest number. And by the way, why is 30 coming before 40, but 500 before 100 and 2000 before 1000? That's because sort is what's called a stable sort, that if two values have the same sort value, then they will be kept in the original order. So yes, 1 comes before 500 in our code here, because 1 has only one digit, whereas 500 has 3 digits. But 500 comes before 100 because they both have 3 digits and they will remain in their original order. That's a stable sort for you. So what if I want to sort these sublists? I have a list of lists here, and I want to sort them by their means. So I define by mean of one list, and I return the sum of one list divided by the length of one list, and that returns a float. And so now I can sort them by their mean. And here we go. Now I have by the mean of each of those individual lists. What if, and I know this probably is something that you have to do at your work, wherever you work every day, you want to sort a bunch of words by the number of vowels they contain. So here we have, this here is a fascinating, scintillating test, and I'm going to define by vowel count. And what am I going to do? Well, I'm going to set up a total. I'm going to iterate over the word one letter at a time, and if I see a vowel, I'm going to add 1 to that. I'm going to return the total. Notice also, I'm going to have a print statement here called the print. So as we check each word, we're going to print out that we are checking it. So now I'm going to apply this. I'm going to say sorted to words, key equals by vowel count. And so what is it going to do? It's going to invoke my function on each word, get back the number of vowels in that word, and sort by that. And so we see this here is a fascinating, scintillating test, and then it sorts it by vowels, right? We have by 1 vowel, and then by 2 vowels, and then by, I guess that would be 3 vowels and even more vowels. And so this works just fine. And we can pass any function we want in there. Here, let's do something like this. How about sort file names by file length, not the length of the file name, length of the file name refers to. So I'm going to import some stuff. I'm going to import glob, and glob is how you get those patterns on the command line, like star.txt or star.exe or something like that. OS will help me deal with the actual file. And I'm going to say here, def by file length, file name. So given a file name, I'm going to run what's called OS stat, which gives me statistics about a file. I'm going to ask for a particular st.size, meaning the size of that file in bytes. And then I'm going to say, okay, return sort of glob.glob star.txt, meaning find all the txt files in the current directory. That gives me a list of file names. I'm going to sort those by the length of the files. And this is what I get for the files I had in the current directory, from the shortest to the longest, right? It just works. What if I want to sort file names by the number of vowels the file contains? Well, that's actually not so bad either. I'd say by vowel count. This is another function of file name. And now we're just going to do exactly what we did before, except instead of iterating over a string, we're going to iterate over the elements or the characters in the file. So for one line in our file, for one character in the line, if the current character is a vowel, then add 1 to the total and return it. And so now I can sort not by the length of the file, but by the vowel count. And sure enough, I get the files back. What if I have a list of dictionaries? can I sort this? And notice the dictionaries, they're like dictionary records. I'm sorry, they're like database records where we have first name, last name, and age. So this is my 3 kids. They don't mind appearing in my presentations. At least that's what they said a few years ago. But my wife does mind. So there you go. So anyway, I have this list of dictionaries. What if I just run sorted on this list, sorted on people? Will that work? And the answer is no, it doesn't work. And the answer I get here from Python is you can't use less than. You can't use less than on dictionaries. There is no less than defined on dictionaries. But we can use a key function. For example, let's say I want to sort these people by their ages. I can define a function by age that takes a dictionary as an input and that returns the age value. So if I now say sort of people key by age, sure enough, we get the people from youngest to oldest. Pretty snazzy. What if I want to sort by multiple keys? What if I want to sort first by the last name and then by the first name? Can that work? How would I do that? Well, actually, it's very easy. I have the key function return a tuple. Because if it returns a tuple, Python knows how to sort tuples. We said before that it'll look at index 0, and then it'll look at index 1, and then it'll look at index 2. So if I return a tuple, I'm returning something that's comparable, that's sortable, and then we're in good shape. So I'm going to say here def by last first. It's going to get a dictionary's input, and it's going to return the last name, comma the first name, which returns a tuple. And so now if I sort the people by last then first, so we get me first, as appropriate, because my last name is shorter than my children's last names. And then each of them in first name order, because they have the same last names. Well, this is fine, but these key functions seem really, really small. Why would I necessarily want to write a key function? Maybe, because I'm just defining it, I'm using it once. I could do better with lambda. Now, what does lambda do? Lambda returns a function object. Remember when we use def, when I say def for function, I'm doing 2 things. I'm first of all creating a function object, and then I'm assigning it to a variable. So basically, if I use lambda instead, I just define a function, and then I can put it straight there inline inside of my call to sorted. I don't need to define a function. I don't waste that variable name. And this is how it would look. So I'm going to say sort of people, and my second argument is going to be key equals lambda of d last d first. We don't even say return in a lambda. It's just one expression, and that expression's value is returned to us. And sure enough, here we go. I return last and first. But I don't even have to do that. Lambda is frowned upon if you don't have to, and there is a method called operator, a function called operator item getter. So I just say key equals operator item getter of age. And what does operator item getter of age return? It returns a function. So I can just say key equals that, and we get it back, and it sorts it just fine. What if I want to sort by multiple things? For example, by last name, first name. Oh, that's not a problem. I just call item getter with more than one argument, and it works just great. What if I have objects, right? What if I have a person object instead of a dictionary with first name, last name, and age? So I create a list of these person objects. Can I sort them? And the answer is nope. Once again, I get this error. Less than is not supported between instances of person and person. So what are we going to do now? Well, actually, we can define LT, dunder LT, and this implements the less than operator for our object. And so all I have to do is say return self age is less than the other age. And if I do that, then I can sort things just fine, and it works great. But what if they have the same age? Well, let's define then 2 methods, dunder LT for less than and dunder EQ for equal. And then whatever's on the left side is going to be passed as self as the argument we're working on, and whatever's on the right side is going to be passed as other as that second argument. And so now I can sort by age even if the ages are equal. What if I want to sort by both last and first names? Well, I just do what we did before as functions, but now I put them as methods. LT and EQ, we're going to return the list of last and first versus the list of last and first from self and then from other. And then we say equal also list from first, from self and list from other. And it works just great. Now I can sort people by last name and first name. Well, what about other comparisons?
That's wild. That you just have to kind of tell it how to sort it, right? And then it sorts it just fine. That's
Right. We're not even
Python
telling it how to
blows my
sort.
mind.
Right. Right. We're telling it this is how you say this, A is less than B. This is how you say
Yeah,
A is equal to B. And sorting just falls out of that naturally.
it's such a beautiful language.
Like once you sort of peel back the layers and see, oh wait, I can just override these operators in this way.
Yeah.
Right. And like they're like, I don't know, 90, 100, 200, I don't know, there are a ton of these methods that you can override. And it's just, yeah, it's kind of wild stuff. And then it
I,
all comes back to, of course, lists and the fact that lists are then comparable.
yeah. I'm ashamed to say that I only learned Python this year. And wow, it feels like coming home. It's so simple, right? It's like, where has this been my entire life? It's been here. I just haven't been looking at it.
Well, first of all, it's thanks to people like you that I have a career, so it's fine. Right? Like I've been using Python for 30 years, more than 30 years, and like, but there are so many people always like coming in and trying to learn it. And yeah, like I have a friend who did a lot of R for many years, and he's been learning Python. He's been taking my courses in Python. And he's like, oh, I see. It's very deep, like this sort of stuff about comparisons and operator overriding. They really thought very hard about how to open this API to anyone to do anything, right? It's like really, really very, very well designed. It's very impressive.
Yeah, I really like how the assorted key thing. That to me sounds like it's just creating a dictionary in the background and sorting that way.
Exactly. That is precise. So that's why the function runs once on each element before the sorting really happens. It's creating, as you say, a dictionary in the background there, and
Yeah,
then it's just referring to that dictionary for how do I compare it? How do I compare these things? Yeah,
it's
exactly.
gorgeous. It's so pretty.
Well, the problem is I've got less than I've got EQ. What if I decide to be like sneaky and I say, I want to find out, is this greater than or equal to?
Right.
And then Python's like, no, you can't do that. I don't know. Like I can compare people if they're less than others, right? I can compare them if they're equal to others, but I can't compare them if they're greater or equal to others because I don't know. Right? Greater than would work because it knows it's neither less than or equal. But greater than or equal does not work because it doesn't know now. So how do I do that? Well, I could define dunder GT for greater than. I can even define dunder GE for greater than or equal. But there's a better way to do it. There is a total ordering function in Python, and I apply it as a decorator, right? Meaning something that's going to modify my class. So if I have LT and EQ, just those two things defined, and then I apply functools total ordering to my class, now I have, as the name implies, total ordering. It now knows how to do greater than, less than, greater than equal, less than equal, all those. It just comes out of that. And it works beautifully. So now if I say print people 1, greater than equal people 0, true, right? It can do that just fine. Now the thing is, we don't even have to work this hard. If we want to create a class, we can now use what are known as data classes. Now they reduce our code by a lot. They have not taken off as much as I expected, but for simple classes, they're actually pretty cool. And they handle sorting also. So if you have a class that has very few methods, it's like mostly data, that's the name. So I can re-implement my people class or person class as this. I say from data classes, import data class. I say at data class order equals true. That's, again, a decorator. It's describing a class. And then all I do is I say person is first is a string, last is a string, age is an int, end of story. And now I can create a list of people using this. And because I said order equals true, it implements that ordering. Now, how does it implement the ordering? If I sort them now, it's going to be in this order. And you can see then it's sorting primarily by first name and then by last name. Why is that? Because it sorts them in the order that the attributes were declared. So because I declared first, last, age, that's going to be the sort order. So if you want to modify the sort order, you change the declarations. So if I now say first, last, then first, then age, that's the way it's going to sort these things. And if you're saying, wait a second, since when do we have declarations in Python? Since when do we say that this is going to be a string or this is going to be an int? This is something known as type hints or type annotations. And they're used primarily to not the Python language itself stores that but doesn't care about it. But they're used so that your functions can then be type checked by an external program, typically something like MyPy. But here it's being used, or if you will, abused, so that we can do sort ordering. And sure enough, now we get the thing sorted initially by last name and then by first name, and it just works. right? Reflects that. So to summarize, the sorted function really does let you sort anything. And the key, no pun intended to this, is the key function. And you can pass there any function or method that takes a single input and returns a sortable output. You can write your own function. You can use lambda. You can use operator item getter. And you can even have your own classes sort if you define some magic methods. And like, data classes make it even easier if you're interested in writing simple classes like that. So that's all I had to share with you. If people have questions, I'm super happy to answer them.
So I have some questions.
Excellent.
Decorators. For whatever reason, decorators have always hurt my head. And I've seen it explained typically within the format of like, we know that this is true. We know that that is true. We know that this is true. Ta-da, decorators, right? It always feels like the last step. I'm like, wait, what?
So, you are not alone
Okay.
at all. Many people get frustrated, surprised. Oh, I don't know why I have Trainer Weekly listed here, but fine, whatever. But basically, so I gave a talk at PyCon 2019. It was my first PyCon talk about decorators, and like it was by far the largest group I've ever had come to a talk. Like people were really, because people get confused by it. So and actually I gave a tutorial on it at PyCon this year. So if you look up on YouTube, it's called All About Decorators from PyCon 2024, PyCon US 2024. It's a 3-hour tutorial, and I think it'll walk you through things, because you do need to sort of build up an understanding of, okay, this is how functions work. This is what I can do. This is why I'm motivated to do it. And that is, you say there's this ta-da moment, but you have to connect the dots sort of closely to each other in order for things to work. Otherwise, it just gets like very confusing.
Gotcha.
I'm going to take this down.
I think I found it. It was on the PyCon channel. Is that right?
Yes. So it's called All About Decorators. And it's like 3 hours long, and it includes a lot of exercises too. I always do tons of exercises during my courses. Oh, perfect.
Okay. Well, I will definitely check that out. Let's see. I'm going to go ahead and pull that down and just have us. So yeah, I'm going to check that out because yeah, like I said, decorators always. I get the concept, right, of like adding additional functionality, right, but it just, I don't know. My brain just doesn't grab it. So I'll be watching that. Thank you.
Excellent. Sure. And if you have questions, you can like reach out to me. That's fine.
Oh yeah.
Answer questions.
Yeah, absolutely. Any other questions, y'all? Feel free to just throw them here in the chat. I did put that link to the decorators video that he mentioned there in the chat, and I'll also have it in the show notes as well. What's next for you, Reuven? Like, are you speaking anywhere next? Is there anything that you'd like to plug or promote?
So, well, I'm speaking next month at PyCon Taiwan. Taiwan is so amazing. So, like, I've been trying to get back there for a few years. I'm super excited to go there. But for those people who are not, for whatever reason, in Taiwan, I mean, I'll be at conferences over the next year, both PyCon US and EuroPython, and I love meeting people who come to my presentations. But online, like, I'm just constantly doing stuff. I mean, I've got my books, Python Workout and Pandas Workout with exercises. And then if you go to learnerpython.com, you'll see my classes, both free and paid, and subscriptions and newsletters. And if you ever have questions about any of my stuff, just like feel free to drop me a line, email, LinkedIn, Twitter, whatever. I'm very, very happy, as I said, to hear from people and see what I can do to help you improve your Python stuff.
So again, this is all about me. When I was learning when I was learning about data frames and series, right? Like, makes sense. I know what a spreadsheet looks like. I understand that. I find it very frustrating trying to iterate through something that I couldn't look at, right? Like, for example, if you were to import a CSV, like you can't just look at the whole thing like you would with a spreadsheet easily, right? Is there a resource that I can go where you talk about how to try to like extract that information from the series or the data frame, or even how to iterate through that in a way that makes sense?
Yes. So, I mean, I have a Pandas course. It's a monstrously long course that I am going to probably start later this year, redoing. So, like, it's like 14 hours, 13 hours, 14 hours of video, but it will teach you everything you need to know about pandas, except for the things I've learned in the last few years. So like, it's going to be, but anyway, but so yes, you can check out my pandas course. Also, I
Mhm.
do like also Bamboo Weekly, where every week I have like these real world data sets and I say, let's ask some questions. Let's try to figure this out. Let's go through it. And so little by little over each week, you sort of learn how to do that stuff. But you said about iterating over a data frame. I taught a course, I guess it was like a year or two ago, in pandas. It was what I call a micro course. I offer a whole bunch of micro courses to companies. They're just 90 minutes long. And it was about optimizing pandas. And
Mhm.
like in minute 85, I said, oh, and like, I know I don't have to say this, but never iterate over a data frame. And everyone's like, what? Wait, what are you saying? I was like, wait, what do you mean? What have I said? So like one of the worst things you can do in pandas is use a for loop. You never, ever, ever want to use a for loop on pandas on a series or a data frame. It's excruciatingly slow and probably doesn't do what you want. Instead, what you want to be doing is describing the rows and or columns that you want and getting those back, usually using .lock, .loc, or maybe .iloc. And then you apply what's known as a Boolean series to sort of say, I want these things and not those things. But in terms of seeing everything, I just use head and tail a lot, especially head. But if you want to see everything, there is I can't remember what it's called. Is it Mito, M-I-T-O, I think, which is like a visualizer for pandas data frames that you put into Jupyter, and then it brings it up as a spreadsheet. I think that's what it's called, but I'm not 100% sure. They're like a company. Oh yeah, MITO. So if you go
Yeah.
to trymito.io,
Okay.
and I know they're a company that like charges for it, but I'm not sure exactly what they charge for and what is free. I think a lot of it is free. That's worth taking a look at. I think they're basically trying to say, so like I always tell people sort of what you just said, which is pandas is, or a data frame is, an Excel spreadsheet inside of Python. And
Right.
they were like, well, what if we make it look like a spreadsheet too? Wouldn't that make it easier for people? I'm like, that's smart. So don't
Uh,
just stop at the metaphor, folks. Actually make it
yeah.
happen.
I mean, it beats just trying to like beat your head up against Python errors, like, what do you mean I can't do that? Like, right. And even like trying to do like comprehension within those iterables really hurt my brain quite a bit.
My YouTube channel has a bunch of videos about extracting data from pandas data frames also, like how do you create a Boolean series, how do you use .lock, that sort of thing. Because again, like one of my advantages is that I teach so much that I see where people get frustrated. And then I can be like, oh, if I do a video about this, then people will be less frustrated. And then everyone's like, how did you know I was having this problem? So it's like,
Because it's common, right? Like if you
right.
talk to enough people, you're going to find those places where a lot of folks end up getting stuck. So
That's exactly it. That's
yeah.
exactly it. Run in front of the crowd and suddenly you're the leader.
Right, right. Got any other top tips that you want to share for folks that are working on Python?
I mean, I would say a big topic to understand is variable scoping. And I know it's like mind numbingly boring to talk about scoping. It's like local versus global. But once you understand how it works, there are only 4 scopes in Python: local, enclosed, and global built-ins. Once you understand how it works, suddenly a lot of things make more sense.
Right.
So try to learn about that. You don't even have to know about enclosing functions. Like I mean, they're fun, they're interesting. For decorators, actually, you do need them, but like most normal people, most days don't need to worry about enclosing functions, at least not until they're a little more advanced. But just do things, try things, play with things. As I said, I'm big on exercises. I have a lot of exercises like in my books and online things, but like whatever practice you can get is worth it. In fact, if you go to practiceyourpython.com, that's my collection of like practice material for Python. All the exercises I can find, I put there. Probably should update a little bit, but I mean, yes, it mentions my stuff too, but that way you can sort of find exercises that are appropriate for your interests and needs and just keep improving your skills little by little. I mean, Damien, you mentioned before we came on that like, you're learning a language, you're learning Spanish. And
Mhm.
like, I know from learning languages, the only way to do it is to do it. The only way to learn is to do it, make mistakes, laugh at yourself, and then keep going. And the same thing is true with programming languages. Just keep using it, keep making mistakes, laugh at yourself. Hopefully it's just in front of your computer, not in front of an audience. And then, that's my job. I get to make mistakes in front of people all the time. And then keep going.
Yeah.
But
Yeah. What's the Python equivalent of accidentally insulting someone in their native language?
I do sometimes say like with scoping stuff, I'll say, well, we could get around this by using the global declaration inside of our function. So I'm like, but we don't want to use obscenities in this presentation.
Global inside of function. That's funny. Yeah, variable scoping is actually one of the things that is definitely in that multi-step decorator explanation. That is like, okay, got it, and then what? Nope, don't got it. So I will definitely check that out, and I'll also hit you up after the show to get kind of a complete list of the things that you mentioned. I actually have a number of browser tabs open, but I want to make sure that I didn't miss anything. So thank you,
Fantastic.
Reuven. Yeah, I don't see any other questions from the audience. Anyone else? Just feel free to hit up at vbrownbag or Reuven himself with any questions. And if you love content like this, feel free to hit like and subscribe. I forgot to say that at the top. I'm a terrible YouTuber, but I'm getting better. All right, Reuven, thank you very much. I'm going to go ahead and end the stream now. And thanks, everyone. See you next time.
Bye, folks.